Leetcode 104, maximum depth of binary tree. It's an easy problem and can be very easy if you know your DFS well. But since the DFS solution could be written in just a single line or couple lines, and the core of the solution is actually just a single line, we will explore both DFS and BFS approaches and try to compare them. And first of all, let's read the description. So given the root of a binary tree, return its maximum depth. Yep, so what is a depth? Let's take a look at this example. And the depth is basically how many levels we have. So the root is the one at the top. That's the first level. Then we have the second level and the third level. And the output is, of course, 3. And our only input is the root, which is an object of that class, tree node, which contains the value itself. We don't care about values this time, so the numbers that are in the circles and connections to the left and right child, which can be none. So, for example, this one, 9, has no children, meaning that those connections would be left as none. And binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So that's like a formal definition, but to understand it and to not make it overly complicated is the number of levels that you have here. And let's now take a look at the second example. And here they didn't include a picture, but basically they're just 2 nodes, and the first is root and the second is the node to the right. And in this case, the output is 2 because on the root level, there's only root. So that's the binary part, is that we can have at most 2 children, but starting from the root, if there is any, if the root has any child at all, then the depth will be at least 2. Since the second level will be already the children of the uppermost root, and then those children, of course, can have children as well. So let's copy that and think about the approaches. And I already mentioned that we have to traverse the tree. Of course, we have to go as deep as possible and count the levels. So here we have, sorry, not 1, but 3, 9, 20, 15, and what was there? 7. And so that's our example. And this problem tests our very basic, very fundamental understanding of tree traversal. This going through 3 nodes or those circles, of course, starting from the top. And we have 2 ways. DFS, which goes as deep as possible, then backtracks 1 level, tries to go as deep as possible in the other direction, backtracks, and so on and so forth. Up until some condition is met, or up until we explore all the options. And BFS goes level by level. So in case of BFS, we can simply count the levels as we go 1 by 1. In case of this one, BFS. And in case of DFS, we can simply explore all the options and take the maximum out of it. So let's say that we go along the blue path. So first we start at the root, then we go to the left, and each time we go to 1 child, we increase the depth by 1. And so we start at 1, then we add 1, and we have 2. And then we backtrack here, and we try to go again as deep as possible. Here we count 1, 2, 3. Here we count 2. And then we backtrack, we go here. And that's how we explore every single node using DFS. And then we take the maximum of all the paths. And that would be 3 in this case. Yeah. So we can just explore all the paths and take the maximum. And that's it. Yeah. And explore, of course, by going as deep as possible. Go as deep as possible and take the maximum. And that's it. That would be like DFS-based approach. Not this, like this. And we can do it in a single line by going to recursively self max depth. And root left. Or maybe just let's create an additional. No, we don't need to have. Since we either way return int here. Yeah, I thought that we will create an additional private function with a separate parameter for depth. But since we return the depth here, we can just reuse this function. Yeah. So we'll take the max from 1 plus going to the left and 1 plus going to the right. And that's it. The only case left for us is if root at the very beginning is already empty, since it's an optional, it can be none, then we have to return 0. And that's it. Let's try. Yeah, we go in both ways, but first we go to the left, and of course, once we call it, it will try to go, it will call all the inner calls from this max depth function, since we made it recursive right now. Yeah, and it will go as deep as possible using left, and only after returning the final result of this one, it will go inside that one. And that's how it works. And that's it. This was this DFS approach, which is extremely hard. But now the BFS, which we only do for the sake of training here, since the DFS is so common, like in almost every problem dealing with tree traversals, of graph traversals, you would use some version of the DFS instead of BFS, except for certain cases. But because we can use it and we can code it in such a simple manner, let's use the rest of the time to explore this other traversal, which is a little bit harder. And in this case, let's copy it again, copy it here, and separate. We would have to use a separate data structure, which is already additional difficulty, to keep track of the nodes and in the same times the levels as well. And that data structure is usually a queue. That's how it works. And it's usually a queue. And first we put the root. Just put the root on the queue, and then try to explore both children, not like here, just going into one path as deep as possible. Here, both children simultaneously. And then, of course, we add the children of the children to the queue, and so on, up until we reached all the nodes. And the way it will work is the following. We will have initially the queue will only have one element, 3, and then we will pop. So it gets removed from the queue. The queue is empty at this point, but we can explore the children. Children are 9 and 20. Let's move it here. Like this, and we can add them to the queue. Yeah, so that 3 was removed, and we add 9 and 20. Yeah, and that's one level. So each of those rows would be like one level. Not really, not the row here, but each of those inner lists will be in one row. Yeah, since right now we will have to pop, or maybe we'll do it. Pop 9, and pop the whole row. Yeah, so we popped here 3 like this, and yeah, to not confuse you anymore, each row will be one level, 9 and 20. Since we could also make it flat, but I think that this way is a little bit more visible since each row will be like one level. So first 3, then 9, 20, and we can explore both children or how many children there are simultaneously. And now the children are 15 and 7. And 9 has no children. Yeah, and the next value of the queue is 15 and 7. And we pop. And there are no children left. Yeah, and each time we do this pop, we also increment some counter by 1, and that's how we get the number of levels. So let's try to implement this BFS version as well. And let's do it. So from collections, import the queue. And initially we put the root here. And then while queue is not empty, we will do something, but we also need our counter or our depth. And we take the length to explore the whole row, or the level length. So how many elements in one level? By taking the current length of the queue, and then we take new nodes. Node equals queue pop left, and that's how we will get like one level in one inner iteration. Yeah, and the queue will continue up until we explore all the levels. And if there is one on the left from the current node that we appended, you append node left, and the same for the right. Yeah, so both children at the same time. And after that, we have explored one level, and we can increase the depth by 1, and in the end, we can return the depth. So let's check. And let's submit. If node left. And we also need this. So this part is universal. That's runtime 100%, will be 50% by memory. And by the way, I forgot if we run also that version for all the cases, but doesn't matter, should be either way okay. And so that's the comparison between two approaches. Most of the time DFS is good enough and it's easier to code, as you can see, than BFS, but sometimes BFS is better, especially if you have to go level by level.